short video about directing groups on a benzene ring. So what this is about is if you've already got a group on the benzene ring, it affects where the next group will be substituted to, the position it will be on. So for example, if you've got something like if you've got a phenol, the OH is on position 1, so the next electrophile that will come on could go to position 2, 3, 4. Okay, 5 and 6 are the same as 2 and 3 the other way around. So it affects where the position of the next electrophile goes. So there are two types of groups that can already be on the benzene ring, and they affect the way the benzene ring reacts and where the groups go. Those two types of groups are called 2,4 directing groups. Okay, and they activate the ring. They're electron donating. Okay, they donate electrons to the ring to make it more reactive. And the other ones are free directing, and they make the ring less reactive. Okay, they're electron withdrawing groups. So they actually take electrons out of the ring. So there are a few you need to know. We'll look at how they work. So here's a 2,4 directing group. Okay, so with a 2,4 directing group, there's two that you need to know. You need to know that an OH, so if you've got a phenol, for example, that is 2,4 directing, and an NH2, which is an amine, like phenylamine, will be 2,4 directing. So what does that mean? So here's the OH already there, that's on position 1, and so the next thing that will be added to the ring, because it's 2,4 directing, will either go in position 2 or position 4. You can look at position 2 and position 6 as the same. It's just the same position from the other side, isn't it? Okay. So if you think about when we add bromine, we get 2, 4, 6 tribromo. Basically, it's 2,4 directing. So you can see here that if you add a nitrate group to this phenol here, you get a mixture of products. You get 2 nitrophenol and you get 4 nitrophenol. Okay, you get both of those products being produced. An important thing to remember is that an OH group and an NH2 group increases the reactivity of the ring. We've seen that in phenol already, that by donating electrons into the ring increases the electron density to make it react faster as well. Now, if you have a free directing group, the one that you need to know is NO2. That takes electrons out of the ring. So electrons are actually going from the ring towards the nitrogen. So that makes it less reactive. And it has the effect of directing another electrophile to the free position. The 5 position is like the free position from the other side, isn't it? Okay. So here you can see we've got nitrobenzene. We're adding a chlorine to it. It will go to here, it'll be free chloronitrobenzene. Now, you notice that we talked about two other things you need to know about nitrobenzene, and you also need to know about phenylamine. We've seen a lot. We know how to make a benzene and nitrobenzene, but what we're not seeing is how to make phenylamine benzene. And that's because you can't actually directly add an NH2 to a benzene ring. So this actually comes a bit later on the course, but it is useful to know it in this section here. That if you want to make phenylamine, this compound over here, you turn the benzene into nitrobenzene first, and then you can reduce nitrobenzene into phenylamine. And the reaction you do there is you reflux it with tin and concentrated acid. And then just to make sure it's an amine, because you don't want to have it pronotate, don't want it to be a salt, you add some sodium hydroxide. And that makes sure you get the NH2 group rather than NH3 plus group. So that'll be useful because these two, we both need NO2 and NH2. We need to know how they direct, and depending when you do this reaction will depend whether if it was an NO2 group attached, it will be a free director down here. If it was an NH2 group, it will be a 2,4. So knowing how to interconvert between them, or convert at least one to the other, is important in this piece of work. Like I say, we cover it more. We covered this particular reaction. We look at amines, but it's useful here as well. So here's a list of all 2,4 directing groups. You'll see these terms ortho and para as well. 2, I think, think of it as awfully close, ortho, para as an opposite. That's the 4 position. It's a sort of a Latin way of naming it, but we don't need to worry too much about that. Meta is in between, in the middle of free directing. We don't have to use those terms, but you will see them. So you need to know these two, but they could give you a table like this in the exam and expect you to use it with different ones like these. Okay. And for the free directing, the only one you're supposed to know is this one, NO2. But again, they could give you information and you have to use it. What I want to do is have a go at these summary questions that I've pilfered out of the Caboodle textbook, and the answers are on the next slide as well, so you can check your workings, and we'll have a look through this later on. Okay, thank you.